Application on unit conversion of current. Page 94 in the book, copy and complete. From ampere to milliampere, we multiply by 1000. Ampere is greater than milliampere, so 1 times 1000 and 1 is 1000. 100 milliampere to ampere. Milliampere is less than ampere, so we divide by 1000. From 100 from 100 milliampere to ampere, divide by 1000, going backwards by 3 digits, 1, 2, 3, so it's 0.1 ampere. Ampere to milliampere, multiply by 1000, so we move the decimal point forwards by 3 digits, 1, 2, and 3, it is 5 milliampere. From milliampere to ampere, we divide by 1000, we go backwards by 3 digits, 1, 2, 3, so it's 5 ampere. Now voltage. By definition, the voltage across an electric component is the electric energy per unit charge that drives or forces the flow of an electric current across its terminals. Analogy between gravitational potential energy and stored electric energy, or in other words, the voltage here. If we compare the height of the slides shown in figures A and B with respect to the ground, we find out that the height of slide in the figure B is greater than the height of the slide in figure A. Compare the speed of the children while sliding down. The speed of the child sliding down the higher slide for sure is greater than that of the child sliding down the lower slide. So what does this have to do with electricity? If we compare the voltage of the blue dry cell in figure A to that of the car's battery in figure B, the voltage of the dry cell is 3.6 volts, while that of the car's battery is 13.02 volts. This means that the voltage of the car's battery is greater than the voltage of the dry cell. Now, knowing that a small dry cell is used for the functioning of a small electric device like the remote control, on the other hand, the car's battery is used for supplying different electric parts of the car. Compare the intensity of the electric current driven by the two power sources based on your analysis. For sure, the intensity of the current driven by the small dry cell is less than that driven by the car's battery, because car's battery is used to drive and to function, is used for the functioning of different electric parts in the car. However, this dry cell, we need like two of it to be able to turn on the remote control, or to let the remote control function properly. So what is the common aspects between the two examples of the slide and the comparison of these two different dry cells? For this example of the slides, the source of energy was the gravitational potential energy. What is this? It is the energy stored as an object goes high above a reference. So we said that the higher slide has more gravitational, the child that goes to the top of a higher slide stores more gravitational potential energy, and this potential energy is converted to kinetic energy that is revealed as high speed while sliding down. However, for the electric power supply, the source of energy is the electric potential difference. So it is this voltage is stored in the battery, and could be converted to heat if the receiver was a resistor, or to light if it was a bulb, or to sound if we are talking about speakers, or rotational kinetic energy if the receiver of electric power is a motor, for example. So what do we mean by electric potential difference, and how does it affect the direction of current flow? Electric potential difference, so this word is because we are talking about electricity, about electrons, and potential because it has the potential to drive the flow of electrons, and difference because the number of electrons differs between the two terminals. So here the blue circles represent the electrons, and the red ones represent the protons. So if you count them, you can see that in the negative terminal of the battery, the electrons are more than the protons. However, for the positive terminal of the battery, the protons are more than the electrons. So there is a difference in particle distribution between the two terminals of the battery. That's why we say here difference. And this difference gives the battery the ability to drive the flow of electrons. The electrons flow from the negative terminal of the battery to the positive terminal of the battery. Here it's to the positive terminal of the battery, not off.